Hello everybody, welcome to exercise 5. In this exercise, we will learn object-oriented programming. I will cover Python class and object, encapsulation, inheritance, abstraction, and polymorphism. First, let's create a class dog. Here, name and age are the data of dog, and dog has two methods, sit and run. This method, init, this method is called when an object of dog is created. And self means the instance of dog. You can think of it as the created dog object. Next, let's create the dog object. We need to specify the name and age of the dog because there are two required arguments in this method. Self is the instance of dog and will be passed automatically, so we just need to pass name and age. Here we set the name of the dog Husky and the age of the dog as 3. And we name the dog object myDog. We can then call the method in myDog. We can also add new data to an object. Here I add food to my dog. In Python, we can also redefine a class. Here I redefine dog, and the new class will override the old one. Moreover, by implementing the string method, we can customize the executed code when an object of dog is being printed. Here I let dog print out dog name plus its name. When an object of dog is being printed, this function will be called. Now I will introduce encapsulation. With encapsulation, we can restrict access to methods and data. We call these methods and data private methods and private data. To make a data or method private, add double underscore in front of it. Private methods and private data can only be accessed inside the object. For example, we can access secret count inside the object, but we cannot access it outside the object. Here, we can call method count, and method count can access secret count because it is inside the object. We can see the value of secret count this way. We can also access public count since it is not private. However, we cannot access secret count directly from the outside of the object. We will get an error if we're trying to do so. Next, let's see inheritance. Inheritance allows us to define a class that inherits all the data and methods from another class. Let me show you how it works. Here we have class parent, which will be the parent class, and we have class child, which will be the child class. We can let child inherit from parent by writing parent in the parentheses. This way, child will contain all the data and methods in parent. Here we can see child object contains all the data and methods defined in parent class. Now you may notice that this init method in child class already exists in parent class. If we define methods or data that already exists in the parent class, the data and methods in the child class will override the inheritance of parent's data and methods. In this example, when we instantiate child class, child's init method is called. So here we are printing instantiating child instead of instantiating parent. Apart from init method, we also override getAttribute method. If we want to use parent's getAttribute method, we can call it from super. Super means the parent class. So here I call getAttribute from parent. Then I print child says hello. So here we can see parent attribute 200 and child says hello. We can also add new methods and data to child. Here I add child method. Next, let's see abstraction. An abstract class is a blueprint for other classes. We can create a set of methods that is required to be created within any child classes built from the abstract class. And the main goal of abstraction is to handle complexity by hiding details from the user. To implement an abstract class in Python, we need to use the ABC module. First, we create an abstract class animal. To make animal abstract, we need to inherit ABC class. Next, we create abstract method eatGrass. To make eatGrass abstract, we add this addAbstract method above it. Any class that inherits from animal will be required to override all the abstract method in animal. Here, we define cat class, which inherits animal. We need to override the abstract method eatGrass. If we don't implement eatGrass, there will be an error. So let's remove this eatGrass. There will be an error because we are required to implement this method, because this method is an abstract method. Finally, let me introduce polymorphism. Polymorphism means many forms. For example, function len can return the length of a string or a list. Polymorphism is also often used with classes and inheritance. Here we have three classes: cat, bird, and fish. Now, let's create the object of cat, bird, and fish. Here I create Kitty as cat, Patty as bird, and Jelly as fish. Kitty, Patty, and Jelly are objects of different classes, but we can use them in the same way with a for loop. This is possible because of the polymorphism feature in Python. Moreover, cat, bird, and fish, they all inherit from class animal, and they all override the sound method. The fact that we can create a method that have same name as the method in the parent class is also because of polymorphism. Finally, Kitty is a cat, and it is also an animal. So Kitty can have many forms. This is also because of polymorphism. Okay, this is the end of exercise 5. Thank you for watching.